Hello Year 6 and welcome to your final chemistry lesson in your Year 6 to 7 Science Bridging Unit. In today's session we're going to be looking at solubility, so it's building on from what we started looking at last time. So what we're looking for today is I'm looking for you to be able to explain how a mixture can be formed by dissolving. Now remember, a mixture is made up of two or more different substances that aren't chemically joined together. We're also learning to describe what happens when a substance dissolves. And finally, we're going to investigate the factors that affect how much of a substance dissolves. So first things first, we're going to learn some keywords. So what I'd like you to do is... Hello again, so what keywords did you identify? I'm going to list them, and anyone that you didn't get, can you write down please? So we have got a solution. We have got soluble, which we looked at last lesson. We've got insoluble, which is the opposite to soluble. We have got solubility, which is the title of this lesson. And then we have got the terms solute and solvent. So what I'd like you to do is to have a go at matching these keywords: solution, soluble, insoluble. So let's go through these keywords and check that we have got the correct definition. So we're going to start with solution. A solution is a mixture of a solute and a solvent that does not separate out. So salt water would be a solution, but sand and water would still be a mixture but not a solution. Okay. Next we've got the term soluble. Now soluble means it will dissolve, whereas insoluble means it will not dissolve. So think about our salt and water and our sand and water. The salt is soluble because it dissolved in the water, and the sand is insoluble because it didn't dissolve. We've then got the term solubility. Now solubility, or how soluble a substance is just a measure of how much solute will dissolve. And then we've got the two terms solute and solvent. Now solute is the term given to the solid that is being dissolved, and solvent is the term given to the liquid that it's dissolving into. Now remember, there's lots of different liquids that substances can dissolve into. So we don't always talk about being water, we'll use the word solvent. And there's lots of different substances that will dissolve, not just salt, so we use the term solute. Now these are quite a lot of new terms here, and obviously it's quite confusing because a lot of them begins with the letter S. So it's going to go through them again. So remember that soluble means something will dissolve, and insoluble means it will not dissolve. You've got the term solute, the solid that is being dissolved, and the term solvent, which is the liquid that it's dissolving into. Now when a solute dissolves into solvent, a solution is formed, and a solution is just a mixture of a solute and a solvent. And solubility is a measure of how much solute will dissolve. So now that we're familiar with the keywords associated with dissolving, we're going to look at what actually happens to the solute or the salt when it is dissolved into the solvent or the water. Where does the salt go? And why is it that if you were to take a set amount, a set volume of water in a measuring cylinder or a measuring jug, say 250 millilitres, and you were to add a tablespoon of salt and give it a stir, why would you still only have 250 millilitres of water? Where has the salt gone? Has it disappeared? If you took a sip of that water, would you be able to taste the salt or not? You're right, you would taste the salt, which tells us that the salt is still there, but where has it gone? So to explain this, we need to go back to what we looked at in that first lesson when we looked at the arrangement of particles in the liquid. Now remember, the particles in a liquid are arranged randomly. They're not in those uniform rows like in a solid. And remember as well that the particles in a liquid, they can move around each other, which creates gaps. And you can see in this picture here that there are gaps between the particles that make up the liquid. So if I was to add my salt into the liquid, some of the bonds holding that salt together, holding the solute particles together, can break So these small particles of salt, when they break away from each other, they can go and fill in the gaps between the water molecules. So if you look here, you can see that these salt particles are small enough to fit in between the water molecules. So they're still there, they're just hiding. And the reason that the water doesn't overflow if you have a big water and you add in salt is because of the fact that the salt is just filling up the gaps. It's not taking any more space, it's filling up the space, the gaps between the particles. But what would happen if we added so much salt that all those spaces between the water particles were full up? What would happen? Well, we would say that the solution would become saturated. Saturated just means it's a solution that won't dissolve any more solute at that temperature. And you would notice it was saturated because you would see a layer of salt forming at the bottom of the cup or the beaker or the glass, whatever you're doing the experiment in. And it doesn't matter how much you stir it, it's not going to dissolve. What we're going to do now is we're going to investigate the effect of temperature on solubility. So we're going to look at how does temperature affect how much of the solute will dissolve in a given volume of water. Okay, and we're going to measure this by counting how many teaspoons of salt can we add before we see that layer of salt forming at the bottom of the beaker or the glass, so that we know that the solution has become saturated. So for this experiment, you are going to need a teaspoon. You're going to need salt. You're going to need water and bowls. You are also going to need permission from an adult. Okay, you need to make sure you ask permission before you do any practical work. So the aim of the experiment that we're going to be carrying out today is to investigate the effect of temperature on solubility. And you're going to use 3 key words when we think about planning and carrying out in experiments. Now the first term is independent variable. The term independent variable just refers to whatever it is that you're changing in that experiment. The next term is dependent variable. Now the term dependent variable just refers to whatever it is, that one thing that you're going to measure in your experiment to see the effect of what it is that you have changed. And your third term is control variables. Now these are the variables that you will keep the same. Now at key stage 2, you often talk about keeping things the same to make it a fair test. So your independent variable in this experiment is the temperature of the water. You're going to be changing how hot the water is. So for today's experiment, you'll be using cold water, warm water and hot water. Please make sure when you're using the hot water, you have got adult supervision. Now the dependent variable is, some of you might have written solubility, but we need to be a little bit more clear than that. To a table. Now there's 2 ways you can draw this table. You could draw the table just like this, like it's shown there, where you're just going to do it once. So you'll count the number of spoons of salt that dissolve in cold, then in warm, then in hot. Or you might choose to do repeats. Now repeats will help improve your investigation. They'll make your results and you can check more valid, and you can check the repeatability. So that just means if you're getting the same answers for each test, okay? Now remember, at key stage 2, you talked about things being a fair test. Now, we're not going to use the term fair test, we're going to use the term valid. And to help improve the validity or to produce valid results, you need to be doing repeats. And once you've done your repeats, you'll then calculate your mean average. So just to go through again what we have done today. We have explained how a mixture can be formed by dissolving, and we've described what happens when a substance dissolves. But more importantly, you have carried out an investigation and you've been able to give me a conclusion investigating the factors that affect how much of a substance dissolves. Excellent work today. I will see you soon for your biology work. Bye bye.